Hello, this is John from caveofprogramming.com. In this tutorial we're going to get to the exciting bit of actually colouring our fractal using ranges. And since I chose these colours, just plucked them off the top of my head really, I've no idea if it's going to look good or bad. But after this tutorial I'll try tweaking those a bit, try to get something good. And in the next tutorial I'll give you some exercises with this that you can try if you want to practice C++ a bit more. So in fractalcreator.cpp in draw fractal, here we're going to have to make some changes. So we're going to use these at some point, but before we define the colours we need to get some information about this pixel. So we're just looking at one individual pixel here in the loop where we actually draw it. So the first thing I need to know which range it's in. So I'm going to say int range equals get range iterations, because we need to get the number of iterations first. Let's move that up here maybe. So equals get range iterations. So now we know what color range this is in. We're also going to need the range total, the total number of pixels that exist in this range. So we can get that from m_range totals. And now that we've actually got the range, we can just plug that in right there. We need we need to get the start and end colors for this range. So we can say RGB, let's just make it a reference. Maybe that's more efficient. I'm not completely sure, but when you get a value from a vector, you are getting a reference in any case. So we'll say RGB reference start color equals, and we've got m_, let's check what we actually called that because I don't really remember, m_colors. So m_colors, array brackets range, that's going to be the start color for this range. And let's copy that because the end color is going to be pretty similar. End color is going to be m_colors range plus 1. Remember that the range is 0 base, so it's going to be 0, 1 or 2, but we've actually got 4 different colors because we also include the start of each range. So there's 4 different colors here, and we need for each range, whatever range the pixel is in, we need the start and end color for that particular range. Now we can calculate the color difference, so we can say RGB color diff equals end color minus start color, and we define that operator already. Now when we actually total up the number of iterations up to this, the number of pixels up to this particular number of iterations, we don't want to calculate the total for all the pixels. We want to start with the beginning of the range. So what we're going to need here is the number of iterations at the start of the range. So let's go up here and add that as well. Let's say int range start equals, and that's going to be m_ranges array brackets range. So now we've got the number of iterations at the start of the range. And when we add this up, now the number of pixels within this range that have iterations less than or equal to this one, then we can start counting at range start. So we start at range start number of iterations and go forward to the number of iterations of this actual pixel. And here we need to just create a total. Let's make an int current total, or we could call it total pixels, and set that equal to 0. And then we can say total pixels plus equals, and we need to add on, so plus equals m_, I think we called it, well, let's take a look. So yeah, it's actually a histogram that we need now, m_histogram. So m_histogram, and just I goes in there. So I is the number of iterations, and the total pixels is given by the histogram here. Now for the rest of it, this is pretty simple. Let's actually so we just have to modify this, I think. So so here we've got, this is going to be, let's take the current, we're going to create a number here kind of similar to the hue that we had before by taking total pixels divide by, and we need the total number of pixels in this range, which is range total. And we need that to be floating point division. So I'm going to cast one of these to double, cast either of them to double, and we'll get floating point division. So this is going to be a number from 0 up to 1, and we can use that to multiply the colour difference. So let's say here, so we've got a variable colour diff times that number. So I think that should do the trick. If we do the same for, colour diff.r, if we do the same for the other colours, I think that will give us the results that we need. Let's try this. So R, G and B. Now the big moment, let's just format that. Well, formatting almost looks worse than before it was formatted, but never mind. It's really good to keep things formatted, even if you don't exactly like the formatting. Let's run this, and we will take a look at our picture. So now it looks exactly as it did before. So I'm probably looking at the wrong project here. Yeah, let's compile this one and run it. I'm getting really confused with all these different projects. And this is what we've got now, which is kind of ugly and pixelated, although it does look interesting. So what I'm going to do now between here and the next video is I'm going to just tweak this a bit, see if I can get it looking a bit nicer. I'm just going to tweak the colours, not the actual code, but the colours that we add in main.cpp, so the range starts and ends, and the colours associated with them. So you can go ahead and have a go at that too if you want. See what you can figure out. See if you can make a really nice looking fractal. And in the next tutorial I'll give you some further exercises that you can do with this if you want, but it's basically finished, so I'm going to leave it there. Okay, so until next time, happy coding.